In this video, we're going to look at some more example problems that involve conditional probability. The first problem says, suppose that city records produce the following probability data on a driver being in an accident on the last day of a Memorial Day weekend. So we have a table here. Notice that in this table, we do not have the number of accidents. Instead, we have the probability of getting into an accident. But we will see that the conditional probability works in a similar way. So the first question says, what is the probability of an accident given that it is raining? Given that it is raining, that means that I am restricting myself to looking at the rain row of the table. So the probability of being in an accident is 0.025, and I'm going to divide that by the total probability of raining, which is 0.360. And when I divide those on a calculator, I get 0.0694, or 6.94%. Question B says, what is the probability of an accident given that it is not raining? So now, instead of looking at the rain row, I'm going to be looking at the no rain row of the table. And so I see that the probability of an accident in that row is 0.015, and I'm going to divide that by the total probability of that row, which is 0.640. And when I divide those two, I should get 0.0234, or 2.34%. So question C says, based on these probabilities, do you think that rain makes it more likely that a driver will be in an accident? Explain. So the probability of being in an accident given that it is raining is higher than the probability of being in an accident given that it is not raining. And we can see that the difference here is a little over 4%, or you could say that it's 3 times more likely that you will be in an accident if it was raining, because if I multiply 2.34 times 3, I would get something close to this 6.94%. So the answer is yes. It is over 4% more likely, 3 times as likely, that you will be in an accident if it is raining. Question 2. A single card is drawn from a standard 52 card deck. Find the probability of each. The card is a heart given that it is an ace. So we're starting with the fact that we have our aces. So we have 4 aces. So that's going to be our total amount that we're starting with. And out of those 4 aces, one of the cards is a heart. So that means my probability is 1/4. Part B. The card is black given that it is a club. So again, we're starting with the second part of the sentence. Given that it is a club. So I know that in my deck there are 13 clubs. And then they are all black because all of the clubs are black cards. So that means the probability is 13 out of 13, which is 1. And finally, part C. The card is a club given that it is black. So we'll start with the black cards. There are 26 black cards, all of the clubs and spades. And 13 of them are clubs. So that means my probability is 13 out of 26, which I can simplify to 1/2.